All right, so today we're going to learn some math. Now, our first equation is the square root of 12. The 2 can go over here simply because there's a line of 2's over here that you didn't see before, but they're there. So anytime you have a 2, there's always a place where all the 2's are from. And if we get rid of the arrow, we can also find a way to get this 12 out of the box by creating a imaginary box over here, and then a decimal point of 0.3 over here. So now the 12 is going to try to get to the decimal point, thinking that this is still a square root, because it won't leave this area, because it always thinks that, it's raining outside, so it always needs to be covered. But when it's here, the 12 believes that this is a place where there's no weather that's going to hurt it. And then that's how you get this 12 out of the box. So now that we have this area that has no numbers, we have all these 12 2's over here that can now begin to fill up this box, and it becomes a 2 box. So the square root of all of these 2's is now going to take over this area. Now the 12 over here doesn't remember that one of the numbers is a 2 itself, and so these 2's will keep asking it to join them, but because the 2 thinks it's a 12, it's not going to, so it's going to stay there with the 0.3. And now what we will find over here is that there's a bunch of decimal points that are looking for other decimal points, which are over here. But the thing about these decimal points is that they create a sort of figure over here. So you see that? That's kind of a figure. We don't really know what it is yet, but we'll get to that. So now these decimal points need to get over here, but they don't have any means to do so. So instead what they try to do is they look for a line of 3's. Okay, so here's a bunch of 3's that, you can't really see it. In fact, no, let's do a bunch of 10's. So there's a bunch of 10's over here. And if you look at it, it looks very similar to as if you had a plate and a knife and maybe a fork over here. And all these decimal points look a lot like, like peas. So what we're going to do is we're going to put all the decimal points on here to make sure that it's like you're eating a plate of peas. And then we can use this as a fictional table so that we can add the 1010101, which is just going to be a plate with a fork and a knife. And then also you could put one over here too. So maybe if there's a dog or an animal that can also eat that. So now that we have that, we've managed to get the decimal points over here through kind of the method of a dinner plate type of way. And so now that we have this over here, each one of these will be transferred here, and these 2's will then start to actually want to go elsewhere. So what they're going to do is they're going to trade, I would say maybe it's a number 78, okay? So this is where the 78 2's need to go in order to become a fraction, all right? So all of these 2's need to somehow get out of here and reduce themselves to about 1/2. Now, for that to happen, we're going to have to divide all of these by the decimal point down here, okay? So then once you divide all of this, these 2's start to overheat, right? Because they're a little freaked out by this, because they don't know what's going to happen when they melt into a 78. And what happens is they turn into a half point, okay? If you can see that. Oh, I'm so sorry. It wasn't even in view. So now that we have these that melt into a 1.5, that gives us a fraction. Now, if you notice, the 1.5 is very similar to the 12 that we originally took out of the box through the decimal point method. And now that we have ourselves a fraction, we can kind of find a way out of this fraction by tipping the scale here. So if we put a bunch of these plates over here, this will move it into a diagonal, which will put a 1 and a 2, a 1 and a 2, and this creates a division, which is the exact same thing as the fraction. But now, because this is a line, it begins to block off. See, it falls down, and it begins to block off that box of 2's, and so now the 2's can't get out, right? So now that the 2's are staying there, we can take the square root of 2 and add it to this one over here, which gives you the answer of 736. There you go. Oh, I'm sorry, point 1.